Hi everybody, welcome to Constrained Coding. My name is Jacob Tomlinson. In these videos we are going to be working through various issues on GitHub and try to raise pull requests in under 30 minutes. If you've been here before, you may notice a couple of differences this time. I have a new microphone over here. I hope the sound quality is a little better than the one that was in my headphones. Also today I've got like a little video capture card, and I'm going to be capturing a different machine than I normally work on. So it's a bit of an experiment to see whether the quality is any good. It claims to be 1080p, looks a little fuzzy, despite taking a 1080p output from the laptop I got it plugged into. So today I'm going to be looking at adding CuPy support in Xarray. Now this is like a large ongoing piece of work that I'm doing at the moment, but I'm kind of getting set up, and I thought I'd just do a small pull request, like a testing the waters in terms of Xarray. A little bit of background. CuPy is a Python library that allows you to do array computation and array maths on a GPU in your machine if you have an NVIDIA GPU and the right drivers installed. It follows the same API as NumPy, which is like a popular array CPU library in Python. So CuPy is popular with folks that want to use GPU acceleration. But there's lots of tools out there that kind of have assumptions about NumPy baked in. So something that's come up recently is there's a nice library called Xarray, which I've worked on and used in the past, which is for having descriptive multidimensional arrays. So if you imagine you could represent an array of numbers in code, right, using NumPy or CuPy, and this could be, say, a 3D, 4D, yeah, let's say 4D, right? Imagine you have a data set that's something like ocean temperature. You might have this big array of numbers that represents the ocean temperature over the whole globe. You can have latitude and longitude to describe, the globe surface, and you're going to have depth as well as another axis to kind of, if you have like a full ocean temperature, you might have surface temperature, which would just be one slice. But if you have the full temperature, you're going to have this 3D box that kind of describes the ocean of the world. And then, you might be measuring that over time. So you might have this fourth dimension. So you have all these numbers. You can manipulate a big array like that in NumPy and CuPy, and that's great. But we have these descriptive arrays, right? You have latitude and longitude, and they have values. You could store those values as an array as well. And then, depth it has values as well. And time has values, and they all have their own types and their own things. And so Xarray is this really nice library that allows you to have like an array of data, and then some other arrays that are kind of attached to its different dimensions that provide more descriptive information. It's all built around these standards called the CF conventions. They're like part of this library called NetCDF. It's like not super strict with CF conventions, but it's useful in that world. So Xarray is popular in weather forecasting and climate research and oceanography and geology and astronomy and stuff, places where they have big arrays of data with descriptive metadata. And something we've been looking at recently is adding GPU acceleration to Xarray. So at the moment it's all kind of, there's assumptions around CPU. It's got Dask built in, which is great. I work on Dask all the time. It allows you to do kind of big distributed computation and have big Xarray data sets that are bigger than the memory you have in your machine, and can represent these really large arrays that you might have split over a large compute cluster. But the Xarray is like really nice in terms of describing all of these things. But if you're doing some GPU intensive computation, obviously the most popular and common use case for GPUs is doing like machine learning, deep learning, kind of AI type workloads. But getting your data from some kind of data set you've got from somewhere into some kind of machine learning workflow where you're trying to add, hyperparameters and then train on some kind of predictive element. You're going to do some kind of data wrangling at some point. You're going to have to manipulate your data. Maybe you want to cut slices out. Maybe you want to do subsetting. Maybe you need to do some unit conversions or all sorts of like prep before you hand off to your array library. Xarray is a really useful tool for doing that. And it'd be really nice to be able to use Xarray to do all of this kind of stuff on the GPU. You get some acceleration in GPU land, but then you could just hand off to something like PyTorch and just do your training straight away without having to like shunt the data all over the place or store it somewhere and load it back in, right? If you can do a load of prep in Xarray and then just hand over to something like PyTorch using the CUDA array interface, that would be really, really useful. So I'm starting to have a look at this at the moment. I think it's going to be some interesting work. What I'm going to do today is, in an effort to do a 30-minute pull request, I'm going to kind of, I've already had a chat with the Xarray developers about adding CuPy support. I joined their developer meeting this week, which, you know, lots of communities have these things. I highly recommend people get involved with these kind of meetings. But I kind of asked for some guidance on what I should be doing and how I should be adding things. And one of the first things that they suggested is that I add some unit tests. I have a look at what functionality like works today. Some stuff does seem to work, some doesn't. So have a look at things that does work, add some tests just to kind of get things set up, and then you know, maybe add some tests that pass on today's functionality and make a pull request and get that in. And then as I'm kind of working, continuing, start writing tests that fail and looking at tweaking Xarray code to get things working. So I think for this stream and video, I'm just going to play around a little bit in Xarray. I've already done some preliminary stuff. I'm going to add some tests just to make sure that the test suite is kind of working. And we're gonna have a little bit of a look at PyTest and how we can do some things in there. And then we're gonna play around with CuPy and Xarray a little bit. We're probably going to see lots of error messages, and that's fine. That's kind of what we're expecting at this stage. So I'm going to swap over to my HDMI capture. I'm going to start my 30-minute timer, and we'll go for 30 minutes from here. Okay, slightly blurry. This is my my Linux laptop, which has it's like a low-end NVIDIA laptop GPU, right? It's a 1050, but it's enough for what we're doing here. So if I, you know, I could do something like, if I pull my terminal up a little bit and run NVIDIA SMI. Oh, that's interesting. I've already messed this up. That's amazing. I do not have my NVIDIA GPU enabled. So let's select my NVIDIA GPU. And I probably need to reboot this machine now. Lovely. Okay, that's not super helpful. I'm going to swap back to my intro screen just while I reboot this thing. That's a shame. Luckily, it's a nice Linux laptop. It should reboot pretty quickly. We should get back in super fast. I am going to cheat a little bit here and restart my timer as well, just because I didn't really think about things, and I'll swap back to the screen. So what might be a useful thing to think about? So Xarray has this like internal data model, which is often represented by NumPy or Dask arrays. So what we're probably going to look at doing is just, we'll add some tests to just make sure that CuPy import works, and also that when we don't have CuPy, we can skip on that. And then we're also going to add some tests where we just kind of cast the internal array to CuPy and then do some work and just make sure that that work is happening. So I'm nearly there. Let me just pop open a couple of things. My web browser and my terminal. Yeah, that's fine. Restore my session here, and let's Visual Studio Code again. Okay, let me swap back to my HDMI capture. We'll start the timer again. Apologies. Oh, I've not got display mirroring turned on. That's annoying. I had that set before. It's obviously forgotten about display mirroring. So let's mirror my displays. Make sure that this is set to low DPI and apply. This before, I need to change my DPI settings here. Fine. I need to, yeah. Keep that configuration. Now, the annoying thing I keep finding, I'm using elementary OS. I'm going to waste my whole stream just messing around with my settings, aren't I? Right, let's keep that configuration. Then back to loop. There we go. Keep this configuration. That was frustrating. Right. VS Code. Open. I'm in Xarray already. I've got a conda environment called Dask, which has just got everything installed in that I tend to work in. So let's just use that. Let's just run NVIDIA SMI. Hooray! that's more what I was expecting to output. So that was a good use of 2 minutes. So you can see here we have some information on the GPU in my machine. So I have a GeForce GTX 1050. It's like a low-end gaming GPU that I've just got in a laptop. Just allows me to play games a bit portably. It's just a personal machine of mine. There's a few processes already running because my display is being driven by the NVIDIA GPU, but we can also use it for doing computation as well. So let's have a quick look. This is Xarray, and I've also got it open in Firefox. A bit small. Open that like that. Make it bigger. Yeah, we can see that. Right. I opened this issue before just to kind of continue the conversation that I'd had with folks in their meeting to say I want to start working on things. There's a few nuances about CuPy that we might come to in a minute, and some folks offering to help, which is good. So people are like interested in this kind of work and this kind of change. Now let's come back over here. So before we do anything, let's add a test. I always like to start by adding tests. I do have the like test suite set up. No, I don't want to do that. And I should be able to discover all of that. Yeah, they've got a load of unit tests already in Xarray. I might actually. Oh, is that all right? Yeah, that's right. I just wanted to zoom out a little bit. Right, so we've got all their tests, and I could run various tests if I wanted to. Hit play, run through a test file, tell me whether it passes or not. So we want to start by adding our own tests in here for CuPy. But doing tests, like running tests for GPUs, you need a GPU to do so. And a lot of projects like Xarray have automatic continuous integration set up on their project, and so they are running on whatever infrastructure they're running on. I haven't even checked to see what they are using for their CI. Azure pipelines, by the looks of it. Okay, so they're running some Linux tests and some macOS and some Windows and some various bits and pieces all on Azure pipelines. But I would assume that they're not using any infrastructure that has a GPU. So we won't be able to run any GPU like unit tests. But we want to add GPU unit tests and make sure that they're like exist in the project so that when I'm working on things, I can run things locally. Maybe we set up some alternative CI in the future. I don't know. But for now, I want to make sure there's tests, but that those tests are skipped. And there are a few other things, a few other test suites in here that already skip. So I'm going to have a quick look into Xarray and then tests. Let's make a new file, and we're going to call it test CuPy. Oh, I don't know why I'm in caps. Test CuPy, and we want to import PyTest. And so we need CuPy, so we could do import CuPy, but that means that our test is going to fail here because we probably don't have, like, it'll work for me on my laptop, but it won't work in the upstream CI. So instead of doing import CuPy, what we actually want to do is CuPy. Let's just check. Let's have a quick. Oh, have I managed to put that inside that cache folder? Done that. Move that up there. Right, let's have a look at test dask, because they've got the same kind of thing, right? They've got this pytest.import or skip dask. This is saying, instead of importing a thing, can you do this? And this is a little helper in PyTest that says import or skip. Switching from Mac world to Linux world, and I haven't remapped my keys. So pytest.import or skip CuPy. What we have now is we have CuPy like kind of imported, but what will happen here is on my machine it'll import CuPy, whereas on the CI it'll get to this point, it'll say import or skip, it'll try and import CuPy, it won't be there, so Python will raise an import error, and PyTest will go, okay, this is missing, you've said import or skip, so I'm going to skip, and it will mark this whole test file to skip, which is fine. It means the upstream CI will just carry on. It will mark it as like, oh, these tests were skipped because there was a missing dependency, and that's it. So we're not going to break anything upstream. We're not going to get the benefit of having CI as we make changes running against CuPy, so we might need to think about that later. But for now, we're going to do that. So what I want to do next is I want to add a little test to make sure that on my machine I actually have CuPy. So let's do def test CuPy import, and let's just assert CuPy. The test should always just have assertions, right? We should just assert everything. Test should just be all assertions, no other code. You need other code. But I'm just going to assert that CuPy exists, that it was a thing. You could even assert like something is in CuPy's docstring or whatever. But I'm going to assert this for now. Let's come back over to our test explorer and rediscover. I could do all this with PyTest on the command line, but I quite like this little test explorer in VS Code. We've got our test CuPy file that's popped up. We've got our test CuPy import. I'm just going to run this file. This assertion should pass. Yes. Okay, and it was not skipped. I could, for example, let's do something that does skip. Let's do like I don't know, foo library equals. I'm just kind of showing it here, right? Foo library equals PyTest import skip foo library. Okay, like foo library, I hope doesn't exist because I've just made that up. So if I now hit play here, that should fail. And you see we've got the little skipped icon here. Say, oh, we tried to import foo library, but that didn't exist. So I've skipped over this thing. Now you can do this at like the top level, like I have done here. There you go. You do this at the top level. You could do this inside the test as well, which I think we should skip individual tests and not the whole suite. So like I get this little run dialog here, so I can hit run, and that one test will run. I could also add a breakpoint and hit debug, and we should launch a debugger into our test suite, and I get a breakpoint here, and I get a debug console. So I could do like GPU array equals CuPy.random.random. Let's make it a 100 by 100 array. That worked, and we have gar, which is an array. Lovely. So CuPy is definitely there. It's definitely working. I mean, let's come out of my debug session. That's enough to be happy that CuPy is there. And so I'm already now starting to add. Lovely. That's super useful. Let me have a look at that. Thanks, Tom. So Pint was integrated into Xarray a while back. So let me pop over to that issue. What is that? 3594. 3594. Okay, it says 3238, which is a PR. Does that as well. That does the same kind of thing that I'm doing here. Go straight there. 3238, 3238. Excellent. So yeah, there's some dependencies added here, but I guess that's because in CI we want, you can actually test these things. There's no like hardware requirement here. So Pint's being added to all those. There's some info in here. Setup.cfg. Okay, I'm missing imports of MyPy. Have a look at that diff. These are the kind of tests I want to be adding. Okay, interesting. There's some info here about NEP18 saying that this is kind of skipping if NEP18 is not active, which will be removed once Pint supports NEP18. So NEP18 is this like array compatibility thing in Python. Hopefully all of this stuff. We're getting to a point where arrays are reasonably interchangeable. They're not perfect, and we'll probably come across some of that with CuPy in a minute. But that's great. There seems to be some nice tests in here which are just testing some things. Is there like a fixture up here somewhere being used? But we've got the same thing here. We've got Pint equals import or skip Pint, which is great. So these tests will be useful for us to refer to as we're kind of writing some more things. What I want to do, I think, is play around a little bit with some examples. So let's go to the Xarray examples. There's a few examples in here. There's one called toy weather data, which I played with already. I'm going to do this in I think I'm going to do this in a notebook, although I might do this in a notebook in here. I'm not going to actually commit it, right? But let's I think create new blank Jupyter notebook. make sure we're in the right environment. It was this Dask environment. Okay. So if I import CuPy, yeah, that should work. Great. If you've not used the Jupyter Notebook integration in here, it's awesome. I'm a big fan of Jupyter Notebooks just for kind of playing and experimenting and stuff. Anyway, but I'm going to play around a little bit with these toy examples in a notebook. And then I'm probably not actually going to save this. I just want to kind of explore and experiment to kind of inform what the tests are going to be. So let's see how we do. If I import, if I copy this example, let's come back in code, pop that in here. Right, so importing NumPy, Pandas, Seaborn, Xarray. Looks like it's creating some random data. It's making a Pandas date range, and then yeah, making some kind of making like a annual cycle based on a sine wave, just to show that weather is cyclical, and then it's being like reshaped and popped into like this fake data set. So that's useful. And if we have a look, we get the output here. So this is what an Xarray data set looks like. You have your coordinates. We have time and location that we've created here, and then we've got the temperature min and the temperature max, which are these two like fake variables that we've created here, and they have some dummy data in that. But we can, if we keep running through, we can do things like convert it to a data frame. Look at the head of that data frame. We can, what else does it do? We can describe it, which kind of does some like basic operations on that data frame. Pandas has got this built in, where it kind of just looks at some standard statistical analyses that you would probably do on some data. So you can have a look. So you can see the number of points and the mean value and standard deviation min and the different percentiles and max and that kind of stuff. That's great. That all works so far. I'm just kind of going through to make all of this stuff work, and then we're going to go back and CuPyify it in a minute. So if we plot this data, we can see for like the mean data across the location dimension, we can see that sine wave of temperature that we've generated here. And let's visualize this seaborn. We can see some other information about it. That's great. This is all working nicely. I'm gonna keep going. I'm gonna try and run through this whole like notebook example basically. So we can have a look at some data around probability of freezing. We have a look at a plot of that. We should get this plot out, which kind of shows the probability that it's going to freeze is higher in the winter and lower in the summer, which makes sense. We can have a look at some monthly averaging and things. I think we're nearly at the end of this notebook. I'm just blindly copying some code, but this is code that like new users will experience when they come along to Xarray. So it's the kind of code that I want to make sure works when we start looking at CuPy. Great. That plot looks like the one in the documentation. We're going to calculate some anomalies as well. Have I just done that one? No. Yeah, so we calculated some climatologies and some anomalies. I won't go into the details of what those are, other than the fact that they are a thing that the documentation shows you how to do early on. Yeah, there's 2 more cells, so let's copy these. On. Lovely. Okay, we can see all of our plots. They all worked. This example worked nicely, which is great. Now let's go back up to the top. Let's restart the kernel. So yes, and don't ask me that again. Now what I want to do, I'm going to move this import into here. I'm going to import CuPy as CP, which is a pretty standard convention. So let's create our data set exactly as we did the first time around. But let's add a new cell up in here. And this time, let's have a look at DS a little bit more. So we've got DS, we've got .tmin, which is a data array. And we've got tmax, which is a data array. right? So these are Xarray objects that represent these variables, and they have their kind of time and location coordinates along with their array. Now this is the like internal array of the data set. So if I do like tmax.data, it's an array, and if I call type on it, it's a numpy array. This is where we want to swap things out basically and see what happens. So if I do tmax.data equals cp.asArray itself, and then do type on it, it's now a CuPy array. I'm going to do the same for min as well. It shouldn't matter if I call this multiple times on it itself, because CuPy should just return if it's already CuPy t min. Lovely. One thing I just want to show quickly, actually, if I come into the terminal, if I run, have I got an MV dashboard installed here? Yes, I do have MV dashboard. So this is like a nice little browser utility for like having a look at what your GPU is doing. Let's go to localhost. I think it's 8 on 8.8000. No, it's not. Yes, okay, it's a Bokeh web application, but I can look at things like GPU resources, and we can see my GPU utilization, the memory utilization of that GPU, total utilization, etc. This is like a useful tool for like exploring what your GPU is doing. It also integrates with Jupyter Notebook, Jupyter Lab. So if we were doing stuff in Jupyter Lab, you can see the GPU is busy doing stuff because it's rendering what's on the screen. In other situations where you had like a server or something, you wouldn't see any utilization unless you're actually telling it to do some stuff. But that's useful. We might use this in a bit to see what's going on. But let's close that for now. We've now got these two arrays that are CuPy arrays instead of NumPy arrays. There's like a few things we need to think about. Like obviously this is constructing a fake array, but all of this could come out of like doing xarray.openDataset and giving it a file, and it like loads this kind of thing in. We could even output this to a file and load it back in again just to make ourselves some dummy data that is loaded from file. We need to think about how does a user right at the beginning say, I want to do GPU stuff? Maybe we add an argument to open dataset that's kind of like an asArray keyword argument. So you say open dataset, give it the file name, and then you say asArray equals CuPy.asArray, which maybe does this internally. Maybe the dataset itself has knowledge about being a GPU dataset. We've played around with that as well in the past, but I don't think it matters hugely for the minute. I'm just going to literally play with this data, cast it to this kind of array. We've checked that it is a CuPy array. Now what I want to do is carry on working through the examples and see what happens. So if I do, I'm actually going to break this up. Ooh, I didn't mean to do that. Or that. I'm going to cut that out and just put it in here. So let's experiment with taking our CuPy backed thing and casting it to a data frame. So that's immediately not working. Array object is not producing an array. This is like a okay, we've got a question here. Would it be best to dynamically convert the CuPy array only when requesting GPU operations? I mean, it's difficult because the operations should be like abstracted completely, right? So if you call .mean in Xarray on your data, like you shouldn't really have to care where it runs, whether it's on the CPU or the GPU. It should just run wherever's like most appropriate. But yeah, maybe you should do like mean and then give it a keyword argument of like GPU equals true or something. One of the downsides here is that GPUs are really, really fast for doing lots of different operations, anything that you can kind of parallelize. But one of the things that they're not great at doing is moving, like getting the data in the first place. You have to copy it from the RAM on your machine into the RAM on the GPU, and that can be an expensive operation. So you don't really want to be like shunting back and forth, keeping stuff in the CPU RAM, and then go, oh, I'm going to do a GPU optimized operation now, so I'm going to copy all of this data onto the GPU, do the operation, and copy it back and carry it on the CPU. Like, that is expensive and wasteful. And this is exactly why CuPy is saying the array method is not producing an array. This is because the CuPy developers have made the decision that you're probably doing this by accident. You probably don't want this to happen. This is bad. Don't do this. And they've taken a pretty hardline decision to say we're just going to break the array method, as in we're not going to follow the API that NumPy has set out. And what they've actually done is they've implemented another method called .get, which should do exactly the same kind of thing. You call .get, you get a NumPy array back, it copies the stuff back off the GPU. So we maybe need to think about where this is happening inside Xarray. It's inside this code. Might actually be like a NEP thing that we need to worry about. But into data frame, we need to worry about this. But this is obviously broken already. We need to think about what to do with this. But I'm going to carry on and have a look at some of these other things. So we're going to ignore anything with data frame at the moment. I'm just going to do some stuff with data set. This is probably also going to fail, right? If I do ds.mean, yes, I'm getting the same error here. That kind of makes sense. That's got the data frame as well. So that's also going to fail. This is data set. Okay, so if I do this freeze equals data set, so we're getting the tmin where tmin is less than 0. We're going to group it by month and do mean of time. So I'm hoping that that will work. Yes. Okay, that worked. We got freeze back. And let's just have a look at, like, we've got freeze here. Let's actually have a look at freeze is a data array. So let's do freeze.data. Looks like that. And if I do type freeze.data, it's a CuPy array. Great. So in this example here, we've done like a group by and a mean, and both of those operations acted on this GPU array. Nothing was moved back, right? We loaded our data, we pushed it onto the GPU, and we've left it there, and it stayed there. We've now created a new thing called freeze that's also remained on the GPU. Everything's kind of happening down in that space, and so we should be able to get the performance benefits here. So that's great. That worked. So maybe I want to do something like this. I might actually, as a quick test, I'm going to copy the imports from here because I think they're useful. No, actually, yeah, I'm going to copy everything apart from Seaborn because I don't think I'm going to need that at the moment. But let's come back over to our CuPy tests. I'm just going to import I'm not going to import CuPy like that. We've got NumPy, pandas. I'm not going to import Seaborn for now. NumPy, pandas, and Xarray. And we're going to do something like def test, check mean. I might like rename this and figure this out. I'm also going to make a fixture. Let's say pytest.fixture. I'm going to do def, and I'm going to call this toy weather data. What I'm going to do is where I'm generating this toy weather data here, which is, yeah, we're going to set the random seed to something consistent. And then I'm going to generate this data set and return it basically exactly as is from the documentation. Generate all of that and then return. We've got this toy weather data, which I'm now going to use down here and check mean. Oh, and I am going to make it a CuPy toy weather data. So let's do that. Okay, so I've got this toy weather data. I'm creating exactly this stuff from the documentation, but then I am converting the underlying arrays to CuPy. I'm gonna call that CP because that seems to be consistent with a bunch of other stuff we do. So we're going to do cp.asArray on that. So we should get back this CuPy array here as toy weather data. We'll get this data set. We pass in the fixture here. And now let's do that same operation, which was down here, wasn't it? Where's it gone? Here, freeze. We're going to generate freeze. And then we're going to assert freeze dot data is an instance. We're going to assert that that's an instance of cp dot what was it? cp.core.core.ndarray. Like that. Okay. We're generating our weather data, and we're just going to assert that we can do a thing. Oh, it's called toy weather data, not DS now. Here we go. And I'm going to assert CP here instead of CuPy. So we've got toy weather data, tmin, group by, mean, by doing some operations. And then we're going to assert that the result of that is an instance of CuPy, or is staying in CuPy land. Let's come back over here, refresh Test Explorer, and I'm going to run these tests like that. And they both passed. Okay, excellent. So I'm coming up on the end of my time for this pull request, and I've kind of done a little bit already, right? I've written some code, I've copied some of the examples, made sure that some stuff is working. Now, the next thing for me really is to work out what to do about the fact that array doesn't produce an array. I think in Xarray we're going to have to add some compatibility code that just says, if this is a CuPy array, we need to call .get instead of doing mp.asArray here. In this variable code here, this will need to be like, if is instance CuPy array, data equals like array.get instead of mp.asArray. And we need to be very thoughtful about where we're going to do that. So it's likely we want to do that when we call to data frame, although we may want to support, there's another package called QDF, which is a GPU data frame package. Maybe we want to use QDF instead of pandas in that situation. That might be something worth thinking about. But also in the plotting library, in order for matplotlib or Seaborn or whatever to plot the code, it needs to be back onto the CPU, back into NumPy land. So we should probably think about in there, oh, this is a situation where we explicitly want to go back from the GPU to plot, because we're going to have things. Yeah, okay, so here we're doing freeze.toPandas plot. What happens if I just do freeze plot? Freeze.plot. Are we going to get the same? Yeah, we've got the same error, and that's happening in the plotting code. We've got this to masked array all. Yes, so 30 seconds. Let's just quickly git check out a new branch. And let's say add CuPy tests. And then let's add just that one file, right? That was just that Xarray tests test CuPy. Git commit. And let's just say add initial CuPy tests. Oh, I've not set my name up because this is a new machine. I should put that quickly. Right, I've run out of time. I'm basically going to push that up, and I'm going to say I've added a test to make sure that CuPy imports and skips, and I've added a test which passes. Just make sure that we can do some basic operation on our data. Thank you, Tom. That's super useful. So plotting calls dot value. So we need to work out what happens there. So we need to, yeah, we need to just have a look at, there's going to be some asArray call in here because Xarray will be trying to shape things back into something plottable. So we just need to worry about the edge cases that CuPy are going to be calling. So I'm going to end the stream there. Thank you for watching. I'm going to continue working on this. So if this work is of interest to you, keep an eye on the Xarray GitHub, and I will be raising more things there. I might stream some more of what I'm working on as I progress, if there's little bits and pieces that I think I can do in 30 minutes. So that's all from me. If you want to learn any more about what I'm doing on the streaming channel and how I'm working stuff out, you can go to constrained.dev, which will link you through to the GitHub page. I'm just managing everything as a GitHub repository at the moment. So yeah, head over to constrained.dev. You can see some info about like why I'm streaming and what I'm trying to achieve and the structure and stuff. So thanks for stopping by. Thanks for watching, and I'll see you next time.